Hey everyone, and welcome back to Let's Talk About Data. Today we're tackling a foundational skill in data science, data cleaning and preprocessing. In the real world, data is rarely perfect. It's often messy, incomplete, and riddled with errors. That's why cleaning and preprocessing are absolutely essential. Think of it as preparing your canvas before you start painting. So, let's get our data ready for analysis. On Let's Talk About Data, today we'll cover why data cleaning is crucial, how to handle missing values effectively, techniques for normalizing and scaling your data, how to identify and deal with outliers, and of course, practical examples you can follow along with. Why is data cleaning so vital? Simply put, clean data leads to better results. It improves the accuracy of your models, reduces bias, and ultimately saves you a lot of time and frustration. Remember the phrase, garbage in, garbage out. Let's start with missing data. It's a very common problem. We have a few options. Deletion, removing rows or columns with missing values. But be careful, you might lose valuable information. Imputation, filling in the missing values. We can use the mean, median, or mode. /backward fill, propagating the last valid value. For example, in Python with Pandas, you can use df.dropna to remove rows with missing values. And to fill missing values, you can use df.fillna, mean, df.fillna, df.median, or df.fillna, df.mode. For forward and backward fill, use df.fillna, method equals fill, or df.fillna, method equals fill. Next, normalization and scaling. These techniques bring your data to a standard range. This is important because features with larger values can dominate those with smaller values. Minute. Max scaling. Scales data to a range between 0 and 1. Standardization z-score. Transforms data to have a mean of 0 and a standard deviation of 1. Robust scaling. Less sensitive to outliers. Scikit-learn is your friend here. Using min-max scaler, standard scaler, and robust scaler will allow you to easily perform those actions. Outliers are extreme values that can skew your analysis. We can detect them using visualizations like box plots and scatter plots. IQR method uses the interquartile range. Z-score method measures how many standard deviations a data point is from the mean. Again, Python libraries make this process much easier. Now, let's put it all together. I'll walk you through a practical example, showing you how to load a messy dataset, handle missing data, normalize, scale, and deal with outliers. You can find the dataset in code in the description. Practice along with me, and you'll be cleaning data like a pro. First, let's create a sample dataset with some missing values so we can practice handling them. Sometimes, when missing values are too frequent, it makes sense to remove them. Here's how we can do that. Instead of deleting data, we can replace missing values with meaningful estimates. Mean imputation for numerical data. One common method is using the mean of the column. This works best when data is normally distributed. Median imputation for skewed numerical data. If the data is skewed, using the median is a better approach. Mode imputation for categorical data. For categorical data, we can use the mode most frequent value. Forward fill carries the last known value down the column. This is useful for time series data. Backward fill works in the opposite direction, filling missing values with the next available value. Once missing data is handled, it's often necessary to scale numerical features to improve the performance of machine learning models. Let's look at 3 common scaling techniques. Min-max scaling transforms the data to a range of 0 to 1. It's useful when features have different scales. Standard scaler standardizes the dataset to have a mean of 0 and standard deviation of 1. It's useful when data follows a normal distribution. Outliers can often be spotted using visualizations like scatter plots and box plots. The interquartile range IQR method identifies outliers based on quartiles. The z-score method identifies outliers by measuring how many standard deviations a data point is from the mean. And that's it. We've covered multiple ways to handle missing data, scale numerical features, and detect and handle outliers. Let me know in the comments which method you use the most. Don't forget to like, subscribe, and share. In our next video, we'll dive into exploratory data analysis. See you then.